So Scott, can you tell me a bit about the NovaRay mezzanine connector that you guys have been successful at designing in your SI lab?
Absolutely, Mike. We're really proud of this connector. What we're demonstrating here today is the NovaRay board-to-board mezzanine connector. It runs at 112 gigabit per second PAM4 plus. It has extra margin for even higher performance designs. And what you see here is our connector on our precision printed circuit boards that we use for characterization, and you see it connected up to the Keysight equipment. Could you say a little bit about the equipment we're connected to?
Absolutely. So what we have here is a PXIe chassis that is a modular and scalable vector network analyzer. And you can start with R&D measurement laboratories and have 2 to 4 ports available and develop a test process and then easily scale up to 32 ports, which means you've got 256 S parameters in a single measurement. So with this sort of power and scalability, you can transition from manufacturing and R&D back and forth very easily. So I wanted to take a look at some of the awesome performance you've got on this connector. I'm looking at that eye diagram and it looks like we've got about 750 millivolts of eye height. That's pretty good performance at 112 gigabit per second PAM4.
It is very good because we've designed this to be beyond 112 gigabit per second connector so that your designs are robust and your systems are robust in high volume manufacturing environments. In order to characterize this, we need a minimum of 50 gigahertz bandwidth, and the PXIe provides that bandwidth for us to perform the characterization. We also have other Keysight equipment, 67 and 110 gigahertz VNAs that we also use for some of our characterization. And what you can see is this is such a wide bandwidth connector that insertion loss is essentially flat from DC to 50 gigahertz. Return loss is well bounded at less than minus 10 dB. And if you look at our TDRs, that looks like a little bit of a mess because there's a lot of wiggles in those lines, but that is plus and minus 2.25 ohms of deviation across the connector and the board system. And Keysight allows us to be able to characterize this and refine our process to get these kind of results.
That's right. So looking at the TDR impedance profile there in the upper left-hand plot, it does look like there's a bit of excess inductance and capacitance, but as you mentioned, we're looking at some very precise and blown up vertical scaling on the impedance. And we've plotted all of the various channels and overlaid all of them. So you can see the repeatability is actually quite good. And then looking at the NRZ eye diagram, you can see how we've got very wide open eye, very, very acceptable jitter, and it looks like the insertion loss is absolutely flat over every single differential channel inside that mezzanine connector. So it's really quite an amazing component, and this is going to enable some very amazing hyperscale network physical layer systems to be designed and developed by your customers, I would imagine.
Oh, that's correct. And by using these kinds of equipment, for example, this board is available for our customers. Keysight has them at some of their demos around the world, and by having 32-port VNA measurements, every board that goes to a customer for characterization has already been pre-characterized on a Keysight VNA, and that we provide that information, those S parameters in the reports. Then the customer, probably using Keysight VNAs in their lab, can replicate our results and show extremely good correlation. And I've got to say, this kind of uniformity across multiple transmission lines in a connector is pretty much unheard of in the industry. This is actually performing better than many, many, many microwave connector designs that aren't even that flat. And this is including not just the connector, but also the connector, the board, and the microwave vertical launch connectors.
You know, Scott, that's absolutely right. At these high-speed digital data rates, all of the shortest printed circuit board traces are acting like microwave transmission lines. So you've really become quite the microwave engineering design scientist. But this is what it takes today to design these high-speed digital connectors. And as you pointed out, the physical layer test system software not only gives us the standard S parameters in the frequency domain and the time domain impedance profile, but the multi-channel simulation capability allows your customers to do equalization and pre-emphasis as if their silicon were driving and receiving your interconnect channel. So I would imagine that's a pretty powerful thing for your customers to be able to visualize ahead of time.
Yes, that's absolutely correct. In fact, if my understanding is, in the latest release of PLTS, there now are receive and transmit filters, and there are COM analysis capabilities, and all of that has been built in to make it very, very easy for the customer. So they don't have to go back and forth to other tools and other software. They can see the results in the physical domain and count on them because of the precision and bandwidth of the Keysight product.
Well, I can tell you've done your homework, Scott, because you're absolutely right. The multi-domain analysis of physical layer test system is quite a big benefit that we've had for a while, but the new channel operating margin is a new figure of merit that is just being introduced and emerging in standards. And so our job as test equipment vendors is to try and stay just a half step ahead of all of you designers, which frankly is not the easiest thing, but we've been able to do it, and it's only with the help and feedback from good customers and partners as Samtec.
Yeah, and that's correct. And as you know, it's one of our engineers, Rich Mellitz, who is the evangelist in IEEE for the COM standard. And so we've worked in conjunction with Keysight so that both of us better understand how this is implemented and how it can be delivered to our customers. And it makes it very easy to analyze a system with one simple number and one simple set of simulations, which means it's very fast, and as we all know, time to market, and getting it out of engineering and into the sales group's hand is the most important thing in the universe at all of our companies.
Yeah, well, we try and do our best to streamline the design process. So it sounds like we've done a good job for you, and we're happy to have done that for you.
Absolutely. That's exactly what Keysight has done, and our collaboration with you, Mike, have been absolutely fantastic. We love you guys. And
likewise. Thanks so much. So there it is, signing off from DesignCon 2020.